I'm Adam Krellenstein from Symbiont. Symbiont is a financial technology company working in the space of blockchains, distributed ledgers, and smart contracts, and applying it to traditional finance, in particular to the management, creation of financial instruments. I'm the CTO and one of the co-founders. And today I'm going to talk about actually some of the philosophy behind what we're doing, as opposed to the particular things that we've achieved. It's going to be about why distributed ledgers and smart contracts, and why this technology, and what it replaces and what it does better, and in fact worse than existing technologies. We're often asked, Symbiont is, why we should use this technology. What's wrong with a traditional database, or traditional distributed database? And I think that there's a lot to be said on the subject of how they differ, how these systems differ architecturally, because it really is a new paradigm for how you think about the storage of data and the sharing of information, and the execution of logic. So I'm going to talk about distributed ledgers and smart contracts, what their properties are, and how they work together, and then contrast it with a traditional database system. To start with, I will give some definitions for these terms. You may or may not have heard these terms before. Actually, let's do a quick survey. Who has heard of both distributed ledgers and smart contracts? Okay, that's almost everyone. That's good. The first thing that sparked this industry was Bitcoin, and Bitcoin didn't really use much of either of these terms. Smart contracts have a longer history than Bitcoin, but people don't think about Bitcoin as smart contracts usually. It's a very simple version of smart contract system, and that's because Bitcoin, being the first implementation of these technologies, was in many ways a primitive one. It was specifically designed for payments in a digital currency, Bitcoin, and it's a payment system in digital currency, and that's it. It doesn't fully make use of the revolutionary technologies. Here, though, it does work very well for those particular purposes. So for the definitions, a distributed ledger, sometimes the ledger is called the blockchain, sometimes blockchain refers to both. I like to think of blockchains as just the ledger, just as the data storage layer, and blockchains as being a platform or the underlying system for something more complicated, which involves transaction logic. So you have two things. You have distributed ledger, a Byzantine Fault-Tolerant, log-structured, cryptographically protected, decentralized database. So to unpack that, it's Byzantine Fault-Tolerant. I'm going to give a more in-depth definition of what that means, but effectively it allows for true fault tolerance in a fully distributed and decentralized system, as opposed to one where all the parties have some sort of central coordination. And in particular, it allows for failures due to malicious actors in the network. So you have, in the case of Bitcoin, you have a blockchain with anonymous participants who can attack the network at any time, and from the safety of their basement. Log structured means that the distributed ledger or blockchain is write once, or rather write only, append only, which means that you can't go back and change data. You can't go back and delete history, and this provides for greater auditability. Cryptographically protected means that it uses a variety of cryptographic techniques, in particular hashes and signatures, but not generally encryption, for protecting the integrity of the system. And then it's decentralized. It's fully decentralized and distributed. Smart contracts is something that there have been a number of definitions of before. I like to think of them as self-executing and self-enforcing agreements with multiple parties. Effectively, they're bits of code that execute and represent the logic of what might be a traditional legal contract, but instead are just continuously running programs which implement logic of a system. So here you have the architecture of a traditional distributed database. Note that you have the API clients on the top, you have an authentication layer, you have an application logic system, and then you have the replication of the data. The application logic and the authentication generally are not distributed in the same way as the data. So you can have one set of application logic hitting each node, or you can have different application logic, different authentication, but you're not distributing everything. You're only distributing the data. That's because there's no built-in mechanism for distributing that logic, and that's something that this changes. Here you have an alternative architecture, that of a distributed ledger plus smart contract system. You can see here this diagram puts the smart contract system on top of the ledger, and the application logic and authentication are inside. In the system that Symbiont is working on in Bitcoin and in all of these blockchain technologies, the application logic and the authentication are replicated across every node in the network, which is a peer-to-peer system, and all the peers are generally pretty equal. So this allows for obviously greater redundancy, greater resiliency, and a different security model because you don't have to trust a centralized source of application logic. With a distributed database, you get the benefit of if one server goes down, you have backup servers effectively. And you can even have a rather sophisticated system for failovers. But you don't have a fully peer-to-peer system and fully decentralized the way you can with distributed ledgers and smart contracts. So I'm going to talk about I'm going to break down each two of these properties for each distributed ledgers and smart contracts. Distributed ledgers being fault-tolerant and log-structured, and smart contracts being trustless and peer-to-peer. Smart contracts and distributed ledgers work particularly well together because distributed ledgers provide a cryptographic audit log of information in a distributed decentralized fashion, and the smart contracts are the code which runs on the distributed ledger, and that logic which is replicated across every node, rather than just traditional application logic that's centralized. So to go a little more in depth, Byzantine fault tolerance allows for arbitrary failures of a node. This is not what a traditional consensus model or a traditional distributed algorithm provides for. Normally, something like Paxos or Raft allows for non-malicious nodes in the network. If a node is hacked, the system breaks down. But that's actually a widely used system in, say, Google's massively scalable architecture or something like what Amazon AWS provide. Byzantine fault tolerance is something that's actually much rarer. It's something that both Bitcoin provides and other ledgers and other more traditional algorithms, and allows for a situation where the network comprises mutually distrusting parties, like in the case of Bitcoin, but also in the case of a federated or permission ledger. There are two main consensus models, proof of work and what I like to call actual consensus, real consensus. People talk about proof of work in Bitcoin as being a consensus system. There is indeed a consensus system, but there isn't an explicit communication from node to node as to what the next chunk of data added to the ledger will be. Instead, the nodes in the Bitcoin network all publish what they want or think is the longest chain, and then the longest chain is the one that's taken as the truth. Instead, the way people actually think of it, and what's actually the way it actually works with more traditional systems, more traditional Byzantine fault-tolerant systems, is where there's actually an agreement process where every node talks to every other and says, okay, we're going to move forward with this data. In a traditional Byzantine fault-tolerant system, as opposed to Bitcoin's, where there's a 51% attack, you need, for F faulty nodes, you need 3 F+1 nodes. And that's a different model, but it also allows for the impossibility of reorganizations and rollbacks. Bitcoin, despite what you've heard, is not actually append-only, insofar as you can have regressions and you can erase recent history up to on the order of 10 blocks being a couple hours. Log structured. So this was one of the more interesting things about the Bitcoin architecture, is that it's truly append-only and what people call immutable. Of course, none of these ledgers is immutable insofar as you can change them by adding information. If they were truly immutable, they would be rather useless. They're also hash-linked, means that every chunk of data, every block in the case of Bitcoin, refers to the exact contents of the previous block, including a hash of its contents, and that's very important for verifying the integrity of the system. Finally, the append-only nature and the hash-linked property of blockchain distributed ledgers allows for a perfect audit trail in the system. You can go back at any time and know that your data is there, know that whatever data in the system was used to generate the state of the network is there, cryptographically verifiable, and therefore indisputable. So smart contracts, putting the way that the code exists in the distributed system is that not only are the data replicated across every node in the network, but also the logic is distributed. That means that you don't have to trust that some central party is executing the logic correctly. You're executing the logic. In the case of Bitcoin, you are verifying every transaction that's on the Bitcoin network. Some of that work is optionally outsourced to miners, but not necessarily. And one of the important, another semi-optional characteristic of smart contracts is that the calculations are deterministic and replayable, meaning you can go back and use that audit log to recreate the current state and therefore verify that it was achieved, reached honestly. And the results are independently verifiable because of those previous two properties. Because of the nature of smart contracts, smart contracts being code that exists on a distributed ledger with built-in cryptography allow for cryptographic on-chain identities. So instead of having that authentication system being outside the replication of the database, you have authentication built into the logic of the code that is replicated across every node. And that allows for all the authentication, all the identities of the participants in the network to be inside the replicated database and on-chain, as it were. The authentication can be arbitrary cryptographic conditions, the simplest of which is what's called multisig. That's what Bitcoin uses, where you say these three public keys or these three identities have to sign this message before it can proceed. In the case of full-fledged smart contracts, you can allow for very flexible notions of ownership and authorization within the system, allowing for the modeling, the accurate modeling of financial instruments in the case of a smart contract. So if you want to say, for instance, you have a stock, some equity, and you want to execute a stock split, you can authorize particular entities to make the stock splits and to record that as an event on the ledger, but you can't do that in simpler systems like Bitcoin, which just allow for multi-signature ownership of tokens. With full smart contracts, you can say these parties are allowed to do this exact operation being defined in the code that's replicated across the system. And peer-to-peer, insofar as there's disintermediation via automation, a lot of manual, difficult processes in the current financial technology infrastructure, such as back office operations, coupon payments, dividend payments, can be automated and made much more efficient via the use of smart contracts. Smart contracts can model those events, those financial events, those corporate events, and in a trustless, replicated, and secure fashion. I'm going to talk about two of the challenges that the blockchain and distributed ledger and smart contract system in industry face. Their scalability and privacy. These are challenges that sort of arise particularly with naive implementations, but they are surmountable. They're ones that Symbiont itself is working on, and which it purports to have viable solutions for. The first is scalability, and this arises from the fact that all the data and logic are distributed, which I said already. That means that you have more replication than you would otherwise, and ultimately it's a consequence of the trust model that all the nodes are distrusted, that you can't trust them to shard data the way that you would in a traditional database, where you say, okay, you take care of this information, I'll take care of this information. And that's more efficient, of course, because you can divide and conquer, as it were. But you can't do that in the trust model of a distributed ledger and smart contract system, at least in the naive interpretation. The same thing sort of arises around global ordering, around computations. So concurrency and simultaneous processing of the computation inside the smart contract system is not... So if you take the naive interpretation, you arrive at security and trust issues that you wouldn't have in a traditional database where everything is just centralized. I'll say that in the case of scalability and privacy, which is the next topic, the system is no worse than existing traditional databases insofar as you can always use the centralized system is a limiting case of a decentralized system. The information is symbol around privacy. Data and logic are distributed, so you're sharing information that you wouldn't normally share, and you have to go through extra measures to protect that. You have to. It's not as simple as you can just encrypt the data and publish it on the ledger, because it's difficult to perform calculations on encrypted data, and it requires cutting-edge cryptography to do so. Briefly, 4 different implementations of these ideas. Bitcoin is primarily a distributed digital currency and payment system. Token-based settlement is an extension of that idea, saying, okay, now we're going to have more than one token, not just Bitcoin the currency, but also tokens representing assets, and then we're going to move them around and settle with them like a payment system that Bitcoin inspired. Then there's Ethereum, which is a full smart contract system, but also a distributed digital currency and designed for public networks and general use, general purpose applications, and it really has the vision of being a world computer. And then there's Symbiont, which is a pure technology company dedicated to applying smart contracts and distributed ledgers to finance, institutional finance, focused on instruments such as loans, bonds, and equities, and is not interested merely in representing the assets as tokens and moving them around, but actual dematerialization of the assets as state on the distributed database and smart contract system. Thank you very much.